Be this one, I believe. Hello everyone, welcome to yet another live stream. Hi there. Hi there, Rolo. Hi there, Black Thunder. Hi there, Overdog. Hi there, Bennett. Hi there, Acronymus. Hi. Hi, Timon. Hi. Timon, you said hi before the live stream started.
Yeah, I realized.
And the reason is not the first time we've done that, actually. By the way, you made some mistakes in the last vid. Acronymus, you don't want to go down this path. You really don't. The reason why is because I saw your comment you put underneath the video. And the reason why you really don't want to go down this path is because your comment said... Hold on, let me find it. There we go. Where is it? It's right here. There we go. The top one. So basically, int usually hold on, because Timon is constantly giving static and it's really distracting me. Timon, turn on crisp in Discord. There we go. Int usually actually is not 32 bits, but rather the address size amount of bits. Well, kind of technically it's 16 bits on a 16-bit architecture with the 3 outputs. Also, long is 32 bits and long is 64 bits. The reason why you don't want to go this part of Acronymus is because on a live stream, when I specifically looked this up, I said that I'm actually gonna leave it in the video. I'm gonna leave in the fact that leave it in as long being longer than int, despite that being not actually true because the long would be a long in that case. Specifically to bait all the nerds from Stack Overflow into commenting it in the description. So you really don't want to go down this path. There are plenty of misconceptions in that video. On the very beginning as well, I mentioned that things are saved the same way in all different kinds of memory, which they are not. Memory is completely different from storage, completely different from cache. Another thing about this is that int is 32 bits, just like a long. Long is 8 bytes. So C types, C date types, where you be. Int, yes, well, that's the short end in it though. Long int is 32. The only problem I have with this is that I don't like this kind of thing. I do remember I double checked it in C as well. Hold on, let me open up my surgery, because I know over there I do have still the file that I used to double check it, which was int C, right? No. Did I overwrite it? Piss off, Express IDF. Topic I know a bit about. I know a bit about as well. The only point I want to make that in that video is that different types have different sizes and are read differently. For practice, I mean, to be fair, people are usually only use longs for anything anyway, because, I mean, why save memory at this point? There isn't really a need to save it unless you actually are creating bulk storage, but if you're doing that, then you're probably not working with memory. Making cache is spreading misinformation on the internet. It's not the misinformation, it's like technicalities, because obviously it all depends on the infrastructure you're making it for. So for example, I've mentioned that long is 64 bits. It's actually not, because what if you're compiling stuff for the 32 bits, then you can't use the long. It's not a thing. I didn't mention float at all. Even though double, the name stands from double precision loading point. So I didn't mention the float data type, absolutely at all. Couple more things there is that with the overwriting as well. As I mentioned, the GCC compiler is a bit more clever than that, but that's topic for a future video. And so on and so forth. There will be plenty of misconceptions and misinformation. Fine, let's call it misinformation. There will be plenty of misinformation in the computer science series, simply because there is no point in me giving actual specifics. No one wants this. Absolutely no one wants me to go into actual specifics of computer science. Because then I would need to zone in on a specific architecture, specific compiler, specific version of the language. And that's way too specific to be useful to anyone. The point is to give an overview of how memory works and explain it, which is, you know, what I think I'm doing so far pretty well. Now, with that in mind, actually, with the next video, I will have to specify the version, the compiler, and the infrastructure a bit more. Because the next video of computer science will be difference between programming languages. And what I want to do over there is I want to just write a simple program that will calculate the factorial of something in, well, first describe it mathematically, then write it in assembly, in C, and in Python. That will be, and in that case for assembly, I suppose I do need to, the infrastructure. Oh, thank you so much for the $10. To charity. Hold on, let me add you. Let me add you the website. Will it be just M? Just a single letter M? What kind of name would you like to take on the website? McKinley. Oh, of course it is. Ah, you've mentioned that last time. McKinley, you know what? I'm not gonna apologize actually. That's on you. You called yourself a single letter M. I'm not gonna apologize for that. I am not in the wrong here. You mentioned that last time, but I will not. I simply will not remember that you are the letter M. Okay. McKinley Turner. That's the name. Amount $10. There we go. Alright, McKinley. 94. 104, there we go. I was aiming for more anonymity. That's fine. I mean, I'm not complaining. It's just that I'm not complaining about you changing name. We have all the rights. It's just I'm saying that I will refuse to apologize for misremembering who you are. Because if you're aiming for more anonymity, then it will make it more difficult for me to remember who you are. I guess all I can say is good job. I mean, if you're aiming for more anonymity, I suppose that means it's working, doesn't it? Anyway, today we'll be doing... What will we be doing today? That's a good question, actually. Today, I wanted to do 3 things. First of all, work on videos, because of course, I've been really lazy as of late, and I need to get back into it. So we'll be working on videos. Good to watch anyway. Alright, bye Stum, bye, have a good one. That would be the first thing. The second thing is I want to work on some electronics. Work with some electronics components, you'll see in a second. And then third, do something mechanical as well. Work with some mechanics and such and such and such. And as such, I actually should start by setting up my webcam, which I have not yet. So give me a second. I need to set it up. I have a new computer, did I mention it? Oh yeah, the title of today's stream was... No, it doesn't matter. Where's the shitpost bookmark with ChatGPT icon? Oh yeah, my old bookmarks are here. I don't know... My bookmarks are a bit of a mess. I should mention. For example... this is is number, is odd, is even, and is 10, all of these packages. So PHP Sadness is also pretty good. Oh, you obviously know what ChatGPT is, I don't need to show you that. PHP Sadness is a great website, just dedicated to things PHP which make me sad, exactly. I don't know why my bookmarks are here. But anyhow. Make a streaming FNAF. Oh, that would be a good idea. Doom 10? Not the 10 though. Doom Dark Ages is coming out in 2 weeks, I think. That would be a fun stream idea. Okay. Let me try it now. Let's see. Do I have an empty USB somewhere? Ah, is that an empty USB? That doesn't feel like an empty USB. You have enough money saved up to play Doom. The nominal question, I'll answer it in a sec. Give me a sec, because this is not cooperating. Ah, I'll need to plug it from behind. Yeah, my monitor just turned off. Okay, give me a second. I can't see those messages. This requires more fixing. I need to buy myself a new DisplayPort cable because this one is also failing me. And this. Ah, damn it. Give me a second. I'm setting it up. I'm setting it all up. Be right there. Okay, I will need to buy a new DisplayPort cable because it is ridiculous the way this one is just refusing to cooperate. Anyway. I feel like a member of just cult Mechanicum, because the thing is, whenever my monitor screen turns off, in order for me to turn it back on, what I have to do is I have to unplug the DisplayPort cable, plug in the HDMI cable from the other monitor, unplug that cable, plug it back into the other monitor, plug in the first monitor, and only then it turns on. And I have no idea why. And I feel like just cult Mechanicum cultist who is just repeating a sacred process, a sacred method to turn on the monitor screen with having no idea why it works. Okay, there we go. We're back now. Okay, where was I? Right, I've set up the webcam, I think. That's good. Okay. How did you even learn that? I tried a lot in order to get it to work, and that was like one of the things I've iterated over. Now if I switch to full camera, then... There it is. Look at that. The webcam officially works. Now, today what I would like to do is... you can hear me good. I would like to... this is a motor. This is a motor that you would normally find in... I know the quality is terrible, but bear with me. This is a motor that you would normally find in different power tools, like drills and so on and so forth. Those are some soft hands. I'm gonna murder you. Now... This is a motor that you would normally find in power drills, in power tools, in power such and such and such, and I have two of them. I have two of these bad boys. The problem is that the gear on top is really small and tiny. So what I would like to do today is I would like to make a connector that connects, an adapter actually, that adapts this gear into a bigger one. That would be a bit easy to work with. And that's why I needed the webcam. That's it. Now back to the thing. What happened to the motion deactivated camera? I had to upgrade because that one just stopped working completely. Okay, let me open up SolidWorks. Oh, this is the first time I'm turning on SolidWorks on this computer. That's fun. Let's fingers crossed that it works. That it's SolidWorks. I'm not logged in. That's good. No, that's fine. There we go. So everyone, how is your day going? Today's video was beautiful. I'm glad you liked it, Maria. I'm glad you liked it. I really am. Today's a day off for me. Oh, that's good. Glad to hear. That's always nice. My SolidWorks just isn't turning on. That's good. Good, how's yours? I'm glad to hear it was good. Planning on some guy on your comment section regarding Hitchhiker's Guide to Galaxy. Oh, you mean with number 43 about it meaning an asterisk? Yeah, I've seen that. Okay. There we go. There we go. It works. It's live. Now, I haven't done anything in SolidWorks since the controller video, so let's hope I remember. First of all, I would like to save it somewhere. Not to the controller, only into the... Let's call it... I don't know, bot for now, whatever, some kind of... Who cares? First... Gears. And then we're going to make... a motor adapter. Okay, and so here's the idea. Hold on, no, normal 2. There we go. Now, what we do is we first sketch. And we sketch what? That's a good question. We need to... Well, actually... Oh, that's a good question, because there is definitely smarter ways to do it. What if adapters mechanics? Relatively well. It's also my day off. Also glad to hear. That's nice. Mickey, do you realize that today is Labor Day? Is it? As if I know. Listen, I'm unemployed. I wouldn't know.
Yeah, it is.
Well, good to know, I suppose. I'm still... For me, it's just any other day. Doesn't matter. Okay, so modeling a gear from scratch would be rather idiotic. And as such, I think a much better way to do it would be to look up SolidWorks how to gear. International Workers' Day. Oh, I see. That's an exercise. That's not what I want. I want just a gear. Circle pattern. Okay, good. Now, how to design gears? No, how to gear? How to top gear? Hammond, you bloody buffoon! I don't want to. Oh my god, turn off. Gears. Yes, there we go. Today's on bottom gear. I've never seen Top Gear. It seems like a fun show, actually. Probably watch it. Hydro matter. Assume that is in the middle of the night. A rare sight. Yeah, exactly. I didn't have to work on video today, which means normally the way I do it is I lie to myself that I'll finish a video before live stream, and then I work on the video the entire day, and then last minute, like half an hour before before it will be too late, I just start the stream. So that's why it usually is in the middle of the night stream. However, today I didn't have a video to finish, so I could just start it early. Okay, toolbox gears. So, all programs, SolidWorks versions, SolidWorks tools, toolbox settings. That's not what I meant to grab. I meant to grab my Firefox just turned off. Wait, no, it's right here. I cannot see things that are open on this monitor screen on the other. That's so dumb. Windows. Why? Oh, that is so dumb. Okay. Make a video on how gears work. I won't make a video on how gears work on account of how simple it is. There isn't really any insight I can teach there. Okay, start menu. Then all programs. I don't have an all programs. I don't have that. Let's go and find toolbox somewhere. Insert? No. Tools. That sounds like it. Configure hardware page. I'm losing my mic. For configure hardware page, click power transmission and then click gears. Oh, what's the equation of profile of involved gear teeth? That's such a boring question. That's the problem. That's the same reason why I don't talk about why I didn't talk about what stack was in the memory video. I don't cover boring technical information in my videos. Like, that information is important if you're trying to specialize something, that's true, but that's not the purpose of my videos. Okay, so let's say hypothetically that I'm already struggling with this very simple page. It's like a find thing. That I always like these, where you can just find options. Will you make the linear algebra video next? I'm going to make the linear algebra video sometime in the future. No, just can you like piss off? How do I find a gear? Design library. That's nice. Oops. Hold on, the stream turned off. There we go, we're back. Toolbox. Added now. That looks like a scam. I know that is inside of SolidWorks, but I mean, that just looks like a scam. Okay, festive. This computer. Single user environment is not recommended to set up multiple user environment. I have a single user environment, don't worry. Now what? I think this one, right? Okay, power transmission, gears. Hell yeah. That seems pretty good. Helical gear. Current operation is completely cancelled. Oh yeah, right. Piss off. X sketch. We got ourselves a gear. That's good. It's pretty good, I would say. The only problem is we got it as an object, which is not quite what we want, is it? Alright, that's Fine. Need a spare gear. No, I don't need a spare gear. I need to figure out how to work with this. It's because there are two options. There's the part modeling and assembly modeling, isn't it? Isn't that why? Yes. I do believe so. Okay. Save read-only files. You have chosen to save read-only files is not the sentence you want to hear. But, so I cannot save this because I dropped it in there. I need to figure out how this works. That's the problem. And that's not easy. Well, it is easy, I'm assuming. It's just that, you know, I'm me. It makes it inherently difficult to do anything. Because right now what I basically did is I overrode. Yeah, we're in the helical gear for. So basically what I need to do is open recent motor adapter. There we go. Okay, cool, neat, fantastic, festive, lovely. Now let's say hypothetically we want to add, hypothetically, an internal spare gear into our pre-existing thingamajig. Do I do it like this? That did not in fact work. Well, you know, a man can dream. So, first let's start by making something, I guess. Good enough. Yes, I agree. Plain, solid. Rock solid. Now, I know, add this in. New folder. There we go. Add to the folder. That didn't work. Okay. If I drop it in right here, I'm just gonna open the file. How do I create path? No, now we're in the gear, which is not what we want. Oh, hold on. Hold on. Okay, that's a maybe. Oh, we need to calculate the module of the thing, don't we? I'm just gonna use an online module calculator because I don't remember the equations. Why would I? I have the internet. Gear module calculator. Hi, the TFTR. Fusion 360 is better than SolidWorks, but I already have SolidWorks. Like around half a year ago, I bought it because I was doing retail therapy. I already have SolidWorks. Okay, pitch diameter. That's so confusing. Okay, so this refers to the one lower. Okay. Pitch diameter. Solid kind of works. I honestly think that the name SolidWorks is misleading, considering how often it doesn't. False advertising. Gears pitch. Which one was pitch? Let me see. Pitch diameter was from middle of. Okay, so from turning point of gear, Okay. It will be like this. That will be 987 millimeters. Semi-solid works. Actually, liquid doesn't. I think 7 millimeters. Now, number of teeth. I need to count the teeth. 1, 3, 5, 6, 8, 10, plus 2, 12. I do have 12 gears, if I'm not mistaken. Calculate. And now let's just round it up to the closest one. Because that's how it works with measurements. With precise measurements. That is how it works. Solid gotta be the second most boring state of matter. What a hot take! Damn. Wow.
I officially do not like you.
24, wait, that's wrong. It depends on the module. No, it doesn't. Uh-oh. 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 Okay, so I guess that... Okay,
Thank you, Immoral. Thank you.
Is that not ISO? Uh-oh.
Solid state physics is the best thing ever.
I mean, sliced bread is also pretty good, but yeah, sure. Wait, were you the one who knew that saying, or were you the one who didn't know that saying? I never remember. Timon.
I don't think I knew it.
You don't know the saying? Okay, well, then never mind.
Maybe I heard it before, but I don't know. It feels so random.
Best thing since sliced bread. Not familiar.
Maybe I heard it before, but
Liquid is better than both. Unusable can become both. I don't mean to blow your mind too much, Black Thunder, but solid can also become a gas and a liquid. I know, it's crazy. Canned bread is better. Beer. Liquid bread. The problem... Oh my god, I'm struggling with this already. Is that not an ISO standard? Wasn't ISO the common... I don't remember which one's the common one. I thought it was ISO. It might be something different. U, maybe? I don't know. Power transmission. Gears. Internal spare gear. So, U and X. There we go. Okay, so that works. Create part. Create part works. Now, module 0.6. Number of teeth. 24. Why is 24 the smallest? I have 12. Why is 24 the smallest? I would very much like 12. Very much. Number of teeth. How do I set number of teeth to less than that? I'm fine. Hold on. SolidWorks create a gear with 12 teeth toolbox. I need a gear that has less. Okay, because I can't really edit this, can I? No, I can only change. When I press a 1, it instantly gets 10 to 100. Which is not what you want. That's certainly a fair bit tricky. I do have to say. Well, that's... Oh, wait, is that the reason? No, wait, that's not the reason. I mean, that's close. If only we could, like, make them, I don't know, more spread out. That would be great. If only we could make them more spread out, that would be just festive. Can SolidWorks import STLs? Yes, it can. I have models of gears, by the way. I do have them. I have used them in the past. They work great. However, this would be the more proper way to do it, which I suppose would be better long term. Haha. That is some video from scratch making. How old does piss need to be before it means you have to restart the video from scratch? Make it. I don't have a set number. It depends. It depends on the intensity of the piss moments. Why is the minimum 24? Maybe I just need to, what happens if I like disregard this and I create a different part? What about you? Do you have a different minimum amount of gears? Well, yeah, you can have 12. Why can't the other one have 12? BS, what it is. Okay, can you have 12? Because not gonna lie. No, piss off. I meant create part, not configure. You clearly can have 12. Okay, so you're gonna have 12. Module 0.6. There, that looks right, actually. That looks really right. Ish. Right-ish. Maybe module 0.5. Right-ish enough? I don't know. Do we round up, down, or to the closest integer? Because we got 0.558. If this is 7.5, then this would be 0.6. Okay, so I could have just undershot it. That's a possibility. Yeah. That's a maybe. That's a probably.
What the hell?
What the hell of what?
I'm just looking at Listen's message.
I don't want the shaft. May I remove the shaft, please? Okay, so we have this gear. We got the top gear, everyone. I'm sorry, what? I would like... No, we don't have the top gear. What happened to my top gear? I want my top... What happened to my top gear? Damn it! I can't drop it in there either. If I drop this in here, then I just open up the... It's fine. I can manage. I can do this. I can do this. It's easy. I can do this. Isn't next video on engineering? Not next, but I mean eventually, I imagine.
Immoral. How do you only have two? Like how? Like two is way too few.
Two is bigger than 0. Infinity times bigger, in fact, yeah? It's a true story. How do I add things in? Do I need to drop them on the top? No. Okay, well, SolidWorks adding things from the toolbox. Not 2D, from the. No, from, right, from, yeah, I did say from. Toolbox, how use. The path appears in zone window. It damn well doesn't. Oh. Why? Why though? Why? No. Don't save. You turned off the entire... You are not real. I refuse to believe You are real, in fact. That is not a real program's behavior. What if it was really big 0 and they're small 2 though? You got a fair point there. Give me the toolbox. Okay, now you. And then what we want is power transmission. Gears. And then you. Create part. 612, that's all correct. Yes. And then this gets created right here. And then what I need to do is some of this has gonna be copies. Okay, how do I add it to the other one? I don't add it to the other one, do I? Yeah, okay, cool. No, that's fine, whatever. So basically we have a gear now. Unless I need to save it. There we go. Unless I need to save it to the place. Can you make it 12 smooth spaghetti and use the lead internal power cylinder to make it? Yes, that's what I'm trying to do, in fact. The problem is I'm struggling with even importing it in, but it's fine. I'm gonna call it the Metal Gear Rising Revengeance. That's dumb. 12. Okay. I've done it. Now you file import. I don't know. I just simply do not know. No, there's no way that's how it's meant to be done. I refuse to believe that. I refuse to believe this. How do you add a gear from toolbox? Because I'm just struggling. Hold on, this is the gear store. Okay. Select the required gears, clear instruments, close toolbox settings. But how do you add it from the toolbox? How do you use the toolbox? Okay, you can add these parts to assemblies. So can I only add it to assembly? Because not gonna lie, that's kind of not what I want. My issue is kind of that the gear I have is a bit too small. If I 3D print it, I don't think it's gonna last. So I would prefer to change it up a bit. Make it as this worth the pain. I'm questioning it at the very moment as we speak. You know what? Screw it. Let's do it. Let's try it with this. Let's just try it, you know. Create part like this. There we go. Then it's going to be I'm sorry, but where's the... Did I already break it? Oh, there it is. There we go. Okay, so modulus of 6. Let's do number of gears something like a modest 60. There we go. Lovely. Now, shaft diameter, let's do it solid 10. And I think that's it. Yes. It doesn't really have to be that thick, although, yeah, you know, maybe I should keep it. Okay, there we go. Perfect. File export. I cannot export as. No, that's probably why. There we go. File export as. Perfection. And then we're going to have the gear. We're going to export it as an STL. Perfect. Gears. Export. That was a very aggressive error for a very everything going according to plan kind of situation. Or if I turn that off, then it turns off the entire SolidWorks, because of course it does. It's fine. Now, the motor adapter, let's make a plane, and let's the shaft size I selected to a 10, didn't I? Which means what we can do is we can just select the plane and sketch a rectangle on it. There we go. Features extrude. We can make this much thinner, it's fine. There we go. Uh, 10. Actually, now I think about this, this sketch is kind of much. Let's do it like a 20 by, I don't know, by 10. There we go. Now you have to be more in the middle. So sketch between you in the middle and you on the side. Let's do it as a 5. And between you and you on the top, let's do it as a 7. Perfection. Now you piss off, extrude like so. Perfect. Now we're going to export it into the place, the same exact one, and then what we're going to do is we're going to 3D print the gear, and we're going to 3D print the base for it, and then we'll just fingers crossed hope that it's all gonna work out just fine. I think it's called testing in jargon, but you know. So then we set it all up. Maybe you should post some of the clips from streams as shorts. I don't have time for this. I don't have time to post those clips. Because you need to like basic edit them, and that takes too much time. Topology doesn't mean in 3D design though. In 3D design, what topology is, there is a way it's connected. It's difficult to explain. Basically, like, it's difficult to explain. Hold on. Let me just set up everything in Bumble Lab, and then I'll explain. Basically, imagine that you treat the vertices like you treat holes in topology. That's the basic idea. It just hit me that this right here will be the exact same size as this right here, which might screw it all up. However, if not, we'll just won't use the base, it's fine. Slice plates, okay. Seems perfectly fine. Then, what else? This seems a bit thick. May we make this smaller? That would depend on the nozzle, wouldn't it? Yeah, I don't think so. That's kind of what I'm worried about. This is reaching sort of the limit of the precision of my 3D printer. Which is precisely why these teeth won't be quite as reliable. However, PLA basic, yeah, print plate, I guess. Oh, my printer just isn't connected? That's cool. Well, good to know, I suppose. What is this for? It's for science. Oh yeah, it isn't connected, that's true. Ah, punch. I would like to know, by the way, that I still haven't recovered from my 2 days ago computer escapade, and as such, all the movements still hurt. Did you hear Jesse in the corner? That's so lovely. Okay, how about now? Is the print available now? It is, great. Bed leveling, send. We be printing. Okay, I think at least. Alright. Fun fact, I found the hard drive in my PC that was just unplugged. It was just there. Like, I literally just found the hard drive in my PC. It was disconnected from it. Oh, did you hear Jesse? That's so lovely. Thank you, Jesse. Okay, now that Jesse's cooking, we're gonna let them cook the thing. And in the meantime... Well, what do we do now? I guess how many terabytes? 1.5 terabytes. It was in there. In my PC. It was not plugged in. I have no idea what's on it. I'm assuming some of my old files, I guess. I think it's my old archive drive. Jesse, we must cook gears, Jesse. Jesse, we must print. Okay, so... there are two important videos I would like to work on. First one will be what's the difference between programming languages, the second one will be the Schrodinger's video. About the Schrodinger's equation. Alright. What a stretch, every muscle in my body is screaming. So, I suppose we can get started with the computer science a fair bit. Still no video on evolution. You mean that myth? Yeah, I don't do pseudoscience. Make it doesn't make it have 30 seconds on its computer or something? I have no idea what you could be possibly referring to. Mathematical. Start by describing operation of was factoring? Was it? Hold on. Factorial mathematics. What is it called? Factoring? Or is it factorial of non-negative integer? Okay, whatever. operation takes a number and multiplies it number by the factorial same number minus 1. Factorialize, I suppose. Integrating complex numbers in matter. Complex numbers being in matter is not that interesting because, I mean, it's just there because of the waves. That's perfectly normal, actually. But I get what you mean. I get what you mean. Fairy sex is the least surprising thing he's done. I'm glad that you're not describing it as an app I have on my device, only you're describing it as an activity I have performed. Great. Multiplied by a factorial of the same number minus 1. Smaller number. We perform the same operation, multiplying by the same number minus 1. Then again, until we reach 1, where we stop. So we'll have the mathematical description, then we'll want like a logic description for what we'll want our programs to do, which is just repeat. Make it, do you believe in this idea of fake it till you make it? I don't believe in making it. I think make it is a plot driven by a big accomplishment to trick you into thinking that you can make it. One must imagine Sisyphus happy. To reach 1 where we stop. I think most of you are... But the... That way, because with that context, we can describe it. This is to make a program. Like big small to make you buy more or less. It's about languages on the computer. It's about what's the difference between programming languages. Like, what is the difference between them? And I think this is actually a pretty fair way to showcase it. I guess the last chapter could be like all the languages. We'll need to write a program that takes a factorial in Python, C, and assembly. You should make a video about how information of DNA gets used to make protein. Any more video? Can we get like 70 more video ideas here? Because my list only has 60 videos, alright? I'm only 60 videos behind. If you wanna add more, go for it. I would love to make...
I do.
Fucking hell.
I wanna add.
So I'm just gonna pick a random video every single time. Oh, that would actually be a pretty fun lottery, wouldn't it? Add all different videos there and then just pick a random one every single time. Should I program whose only allocated RAM is the program space itself? So if you wanna remember anything, you override the program. Genius. Can I see? This to a program. Our programs work. Well, first we start with our basic First we start with our basic number. We check if that number is equal to basic number, and another number we'll call a result. Then what we do is we check if our number is equal to 1. Which will start equal to 1. What we do is we check if our number is equal to 1. If it's not, we multiply the result by our number and subtract 1 from it. Memory leak, wrong. Computer Alzheimer's, exactly. If that gear works, I'll be surprised. Because honestly, everything there is just like so perfect. There's no wiggle room for error, and that's I don't think that's gonna work. If it's not, we multiply the result by a number and subtract 1 from it. By a number, and let us the new result, save our number as the new number, and repeat the process. Keep going and going and going. Number is actually equal to 1. And then, there we go. The result is equal to the factorial. Now, this is gonna be actually pretty fun because we will... Oops, sorry about that. This is actually pretty fun because we'll have to write these programs right now. So let's do it. Hold on, no, that's my website. What I actually meant is cd up, cd program video. What was the name of it? File for... No, damn it, what was the name of it? I forgot the name. Hold on, I need to find it. Computer science video, of course. CD computer science video. Perfect. Now, computer science video, I actually haven't committed anything, so let me just git add a, git add dot, there we go, git commit all the message of video 2, git push. Lovely, phenomenal, fantastic. And now let's add a new folder. Let's call it video 3, into which we'll do factorial.py first. Simple as it could be. So we're gonna start with a number that will be equal to something. Let's set it equal to 10, because why not? Then result, which will be equal to 1, and then we're just gonna copy the entire program we described. So guys, don't break my first. I try to only eat from home or eat healthy. Oh, mental physical health. Good for you, Lycan. Good for you. Moderate after this. That's a great idea, Lycan. I like it. If you were Adeptus Mechanicus, which order would you be? Black Thunder. I would be Dark Mechanicum. Let's be real. I would be Dark Mechanicum. That's not even a question. Also make it, is it not circular reasoning to find the meter as a fraction of the distance the light that goes in certain time? Or am I misunderstanding? Kind of, in a way, it is, yeah. But I mean, that's how we do units. You can't define the distance, you can't define the meter without the concept of length. So the actual circular reasoning is us trying to define length, which we cannot do. But I mean, whatever shall you do? There's just no escaping that. You need to like have length in order to define length. Which one? Okay, so while number is not equal to 1, multiply the result by a number. Result times equals number, and number minus minus. Oh wait, minus equals 1, I forgot Python. And then print the result. There we go. I don't know if that's correct. Let's see. 1. That's correct. 2. That's correct. 3. That's correct. 4. That's correct. You know what? Let me just... Why am I doing it this way? We live in the age of computers. I know, 20, because why not? I. Uh-oh. No, uh-oh, it's not running. Uh-oh. It started at 0, didn't it? It started at 0. Of course it did. Of course. Can we do this? There we go. That seems correct. Certainly does. Buy like and buy. Making alcohol. Be careful, Balin. Do be careful. I wouldn't recommend doing that personally, because it is dangerous to make alcohol. I meant Woodroll, Tech Priest Fabricator. Honestly, don't know much about Dark Mechanicum with the roles. I didn't think they have a hierarchy. What is the one that goes around looking for just experimenting? Well, I suppose in Cold Mechanicum that would be just Cold Mechanicus, whatever you want to call it. That would be the ones that look for STCs. Follow the first rule, have fun. Hi, the Cyan, hi. Did you hear Jesse, by the way? Singing me a song that completed the print. I should go and pick it up now. There we go. I've got the prints. Alright, time to see. Time for the moment of truth with capital T. Alright. Here's the gear. Oh, that actually works quite nicely. I know you can't see it very well, but it is in fact snapping into place. I don't know how well it will work if I don't know how well it will work once it starts rotating, because it's gonna rotate quite quickly. But so far it seems to be snapping into place. It can make the motor rotate. Not that we'll have to replace the gears often, which will be a problem. But they are suddenly snapping into place. And I can rotate the motor using a gear, which is a good sign. I know it's really difficult to see, I understand. Sorry about that, don't have a better setup. You can't see them. Piss off. Okay, so this works, at least it appears to, which means we can number, I don't know, 5, why not? And then this one right here would be just the result. There we go. So the Python script is finished. Now next on to C, factorial C. Factorial C will be a bit different because we'll need to include standard IO. Standard lib, int main. Okay, so first we're going to start with long number is equal to 5. Long result is equal to 1. And then while number is not equal to 1, then what we do is, actually I could do it on a single line. Oh, that would be actually a pretty neat way to finish out the video. I could do it in a single line, but I'm not going for now, which is result times equals number, and then number minus minus, and at the end print. And there we go, that should be it. Yeah, that seems right. That does seem about right. There we go. It works in the exact same way as the Python script, so I don't think I need to check much. And then the last one, factorial.assembly. For which we need assembly, which I haven't done in however long. Was there a factorial here? I don't remember. I don't remember if there was. But hyperbolic tangent should give us a bit of a... Okay. Now what we want is... Good question. This, by the way, is what I made to link it to C. Which is not quite what we want, is it? Yeah, that was back when I linked it to C. Instead... compiling assembly with GCC. .s. Oh, there we go. Okay. Now. The problem is we want to print, which is a problem, because we'll need to call the printf. So we want to print a variable in assembly. We'll need to call it print. For that, we'll need to know which register to put stuff in. Oh, first I guess I should just compile this, see if it works. Video 3, factorial s, test, XC. Right. Okay, do I need to specify what kind? I do also have the assembler. I don't remember which one I was using though. Assembly code. What was the name of my assembly? I don't remember which one I used. Wait a minute, I just realized the build file for my engine is still online, which means all we need to do is just go build.ps1, and over there should be NASM. I've been using NASM. Haha. NASM video 3 factorial s. Damn it. How do I? That is not defined. That is true. It is not defined. You are correct. Huh. That's good. Wait, no. Hold on. That's not good. Because you made an object. That makes sense. That makes sense. I'll need to just compile the object with GCC. Then let's make like a build file. Build ps1, because this is gonna get a bit annoying. So many errors for no reason. Okay, nasm fwin64 video 3 factorial s output test object, and then GCC test object into test exa. Right? I should hope so. No. Okay, well, because we don't have a main. Right, I need to link it then. Ah, damn it. Damn it. Okay, so basically... That's... Okay, so extend define, and then we need to... Alright then, assembly. Let's see. Let me just copy all the typical stuff. Alright, there we go, and then extend. And it's return what? What are you returning? Extend ton age. So let me just let me take ton actually. Just ton. There we go. And then function. There we go. And then in mathc we extend double ton. So this is how we've done it, except right here it's a function. And that's our function, and then what we do is we print f and we just call it, and then with like just some kind of double. So let's do 10.3, because why not? And now if we do the same exact thing, except we also link it to video free assembly, then it breaks. That's good. Why does it break? Oh, it's because we're calling a cosine and we're calling it a sine. Alright then. Okay, baby steps. Let's just try a cosine then. My goodness, my cosine is quite something. This is kind of low-key hilarious. It's a Taylor expansion, if I'm not mistaken. Oh wow, oh wowza. Alright. Undefined reference to func. Why though? Why is it that an undefined reference? I'm fine. I can make this. Func. Oh, that's fine. Unless we need to link it somehow? No, it doesn't make much sense. No, we just add in the O. Maybe you just need O to like know the default? No, of course not. Well, a man can dream. Alright. It's fine, I can manage this. You included MKT Up Engine H. Which is, if I'm not mistaken, Up Engine H right here. And then my goodness, there's a lot of thing in this. Right here they're defined with extend, but so are they inside of my assembly. It's defined as an extend because the assembly is supposed to define it. Yes. That seems to be the issue. Hi to someone, hi.
Hello.
Ah, damn it, Dagnabbit. Dagnabbit, Nabbit, and damn it! Why wouldn't it work? Undefined reference to funk. I would beg to differ. It seems pretty defined in there. Seems pretty defined to me. Unless it cannot be an extend, in which case, why are we even linking it? Assembly C. Undefined reference. Well, that is just curious, honestly. Because the object should have it.
Know someone, I don't even know who that is.
Azali is the creator of such amazing bangers as Please Do Not Listen to the Song.
Alright, I won't.
That's the name. That's just the name of the song. Why wouldn't it work? That's the question. Yeah, right now it will work just fine. That's because we're not using a func. But if we're using a func, then it's not working because we're defining as an extern when it's just not liking it. Even though when building, we do build it with the test O, which should build it properly. So let me take a look at stats. Global, oh, that could be it. That could be it, in fact. Global. No, wait, no, we don't need this. What about, oh no, still isn't. Dagnabbit and fiddlesticks. No, wait, this seems actually pretty correct. Oh! Okay, that's something. Hold on, let me see. If it worked, that's gonna be the coolest thing since sliced bread and then a bit and a half. Okay, no, it can't. Wait, no, it didn't work. To be fair, in my defense, it's a 10 expander, so maybe 1.3 would be a bit more speed. Okay, okay. Let's see. Alright, cosine of 1.3. There we go, that's a pretty good approximation, isn't it? Isn't it? Isn't that good? Look at this. I have just approximated a cosine using gosh dang assembly. That's pretty good. Now, so here's how we'll do it basically. We'll basically remove this because it's not necessary. And on the very beginning, we're going to include... Did I not make a factorial? Oh. I think that's factorial actually. Yup, that sounds like factorial. And it's done the exact way we want it to be done. How perfect. Would you look at that? Which means I'm pretty certain if we just do this and then build and then test. Wait, oh yeah, because we gave it a wrong thing. Whoops. What I meant to do is give it a 5 and read it as a D. What I meant to say was that we should long value is equal to this, and then oh, because we define it as a double. I'm an idiot. Never mind. This should be long racks. We don't need to specify the ranks, but rather, and long, and then if we build and test, this is awesome. This is awesome. Will this be a 6? Oh, that's amazing. There we go. There we go. And Megan has become completely British. No, the British virus. No. There we go. Now what we do here is we first start by moving racks to RCX. Then we compare RCX to a 1. If they are not equal, then we jump to loop and multiply, in which case we decrease RCX, and we multiply ArrayX by R. That's so good, I do have to say. That is so good. That is exactly... Oh, wow, I am consistent. You can say a lot of negative things about me. A lot of them would be true. But at the very least, I am consistent. Because I have made that program in assembly... What is it, 3 years ago? Hold on, let me open back my GitHub. See how many years ago I've made that program in assembly. And the way I've done it was the exact same way I did it right now. I didn't have to relearn anything to plug it in because past make it and present make it transcend through time. I am trans in that regard. When did I... 3 years ago, there we go, yeah, 3 years ago. 3 years ago. See? Consistency, that's what it is. So, the result is equal to factorial. So, let's... with some kind of number first. We start by... there we go. We start by... Actually, we could modify it a bit, now I think about this, because we move ArrayX to RCX, but we could just move 1 to RCX, and then just decrease it afterwards. And that should... Invalid combination of opcode operands. I'm an idiot. There we go. Yeah, exactly. Just minor fix. I'm transcendental. Okay, great. Great festive. This is gonna be a really nice video. I'm gonna explain assembly. It's gonna be nice. It's gonna be sweet. It's gonna be lovely. Alright then. Should I buy on the Pico? I have not done much with the Pico yet. I've been busy. I've made a video. It's my defense. Should I work on the... Well, as fun as it would be to work on this video, to be fair, and as motivated as I am to work on it, the problem is that I can't do too much computer science in a row. I don't want my channel to be a one-trick pony. And as such, we're gonna switch up the topics a bit to the other video I'm supposed to make. Out of the 3 videos that we are working on this stream, because we already did the gears for the first video, we did the setup for this video, now it's time for the 3rd video. This is a very research kind of stream, I do have to say. We are doing research for videos, basically. And now it's time for the 3rd video to research. The Schrodinger's. Which we're gonna start with an introduction, as always, then explanation of Schrodinger's, and then... what was it? I've been talking about quantum mechanics a lot with Remco recently. A lot. We've really been discussing quantum mechanics a lot. And as such...
Can confirm, I was there.
Yeah, Timon was there, exactly. And I've been doing...
Yep.
That's kind of the reason why I've been so fucking lazy recently. Particle in the box. There we go. Okay, so first intro, as always, I leave for later because I don't know where this video will go yet. For now, Schrodinger's. The Schrodinger's equation. And you know what's lovely about this? We can use LibreText. Did you watch the Friedman Brown computing video? I have not seen the Friedman Brown quantum computing video yet, no. I haven't been watching much of Friedman Brown or the science channels on YouTube because I'm afraid that if I watch them, I'll accidentally plagiarize them. That's my reason. Which one was it? Hold on. Oh, that's the Fowler. I like the Fowler textbook. Wait, physical chemistry, what? Why is this physical chemistry? You mean to tell me that I looked up Schrodinger's equation and the first textbook that pulled up was chemistry? I meant the Fowler quantum mechanics textbook. Obviously. You really need to uninstall quantum mechanics. I uninstalled it, Catman, for the 4th time yesterday. Why do you think I finished the video? Keep I'm addicted. Which part of that do you all not understand? Y'all honestly would tell an alcoholic to just stop drinking. The momentum spin hydrogen. We're looking for the Schrodinger's. I just opened the same textbook. Fitzpatrick Vallée. These are the 3 textbooks I've used for my quantum mechanics video so far. And this one appears to have a whole chapter. Okay, as any player knows, there are 3 important aspects to its motion. Position, as any player knows. Oh, that's for Ballard. Okay, I see. It's not understood until you check the entire hard drive, exactly. Position, velocity, and spin. We don't care about spin. We have argued before that quantum mechanics involves an element of uncertainty. You can predict a state in quantum mechanics when you have probability. You want to be able to predict the outcome measurement of, say, position. Hence, since position is a continuous variable, we cannot just deal with a discrete probability. We need probability density, and since factorial probability, yeah. Some aspect of classical waves and see whether they can help us guess how to derive probability density from a wave equation. Wave problems I get given by plane wave. Yup. Using the broccoli relation. We find them to be quantum node is that. Potential, experiment Hamiltonian. Okay, there we go. I have a math exam tomorrow. I'm screwed. You'll be fine. You'll manage. What kind of math exam? What is it on? Using this, we can guess a wave equation of the form. I love that quote so much.
That's a surprisingly common method in physics, that they just guess the equation and then prove that that's the equation.
I mean, yeah, that happens a lot, because actually it's a very reasonable way to approach these things. It's basically, it's much easier. It's actually a principle that, like, created the entire field of AI and, you know, just terms like this, machine learning, where basically it's much easier to check if a given answer is correct than it is to create an answer from scratch. Now, obviously, physicists aren't guessing, they're making very educated guesses, but still it's a similar principle. As you can
Yeah,
guess.
they did actually teach us how to make educated guesses on this.
Yeah, because as I mentioned, once you make an educated guess, it's really easy to check if your guess is correct. Whilst actually building up from the very scratch is difficult. That's why like graphs are so useful in physics or visualizing data. It's because once you visualize data, then that can give you an intuition for what's happening. If some kind of really complicated massive equation, like analyzing a really complicated massive equation is difficult, but if you prop it on a graph and you see that it's wavy, then that can give you some kind of intuition that maybe it has to do something with waves, something with oscillation. And that way you just make an educated guess, and all of a sudden, oh, would you look at that? The waves are actually there. Intro math, this is my third attempt. You'll be fine, third time the charm. That's what they always say. And they've never been wrong. Okay, so energy is equal to this. Makes sense. Alright. Wave equation of the form. And then we move it like so, and then energy is equal to 1/2 mass velocity plus potential, which in this case translates to this, where this is velocity squared. The Planck squared could be translated into mass. I don't remember. It's because of the waves, isn't it? Oh, what was the relation between frequency and mass? Actually, another thing. Oh, fun fact time, and actually the energy transfer video. I'm specifically making the script longer so that all of your hard effort doesn't go to waste. I'm specifically making it longer and actually including more topics.
Thank you.
So, for example, the kinetic was meant to be just a paragraph of text, but I'm changing it to also explain what mass even is, which is really interesting, surprisingly.
That's good because this is a lot of time. Like this is a big task.
I know. Planck squared, you mean floor. If I failed, they would kick me out. You're not gonna fail, Mark. You're not gonna fail. Stop pretending like you will. Because that ain't gonna help no one. Stop pretending like you will fail and then you won't. Simple as it could be. I think I may be focusing on too many videos at once. Shrimp ass, that's true. That is true, it's shrimp ass. Okay, fine, we'll start the computer science a bit more, but I would like to release the Schrodinger's video first. Because I don't... It feels wrong to make 2 videos of the same topic in a row.
Well, it's because it is.
Oh. Promise I really like computer science. It's fine though, I can...
Agreed, that's a problem.
Make it give time in the smaller task of editing stream clips for shorts. That's really fucking boring though. Imagine that if I fail the 3D course while I'm working on the 3D printing service job, being one of the most productive guy in the shop. Oh no! Mark, it sounds like you're having just issues with performing at tests, not issues with standing for those tests specifically. That's why you need to stop worrying. Pretend like it's an everyday thing. If you are actually doing so fine in your day-to-day life, then just keep at it. Pretend it's a normal day-to-day life kind of situation.
Also, immoral. I really like this current task because it just it compiles everything. It compiles my creativity. It compiles my general knowledge in science. I have to do some geometry mathematics thingies, so like this is a super cool task that I have, so don't worry about it.
You're welcome. I could have given you just shorts to edit. See?
You don't like shorts either.
Well, I don't like shorts because they take a really long time to make and I don't respect them. Okay, they don't take a long time to make. They take a really long time to make in comparison how little I respect them.
Yeah, I don't respect them. Like, that's just that's just there to produce ADHD.
I like shorts. They're comfy and easy to wear. 2 rights for a left. Tests are an everyday/week thing for people here. I keep forgetting most people are students, actually. I keep forgetting that most people here are students. It confuses me. I'm having trouble relating. I also have one issue actually. I want to make an axle. I want to make an axle with where I could attach wheels to the sides. The only problem is printing an axle is really difficult because printers don't like wheels or cylinders being printed on the side. Whilst an axle would be long enough that it would have to be printed on the side. I've already got a job, so I don't need a diploma. Just the concept of wasting money on school. I get it. Print it oversized and sand it down. That's so much, comically so much work for an axle. I mean, I guess that's the only solution, isn't it? Yeah, I suppose. Oh well. Anyway, back to the Schrödinger. Schrödinger equation looks terrifying, doesn't it? Actually, this could be the intro. Yeah, I suppose. Make it buy a resin printer. On it! Right away, buying it right now. You know what? I'm gonna buy 2. Just in case. It's gonna make my printing easier. Actually, I'm gonna buy 3 in case the second one breaks. Mount drill plus sandpaper. I don't have a drill. I do comically enough. I don't have any power tools. I need to set up shop somewhere. I thought about getting myself a garage because they're pretty cheap. Like, you know, those kind of, the ones that are made of like the cheap metal panels. I don't know what they're called. Like corrugated metal things. Those are really cheap to rent. They take like, I don't know, $200 a month, 300. And I thought about renting one of them and setting up a workshop there. I have money, I just don't have the resin printer kind of money. Partial derivative letters of extra. Numbers. Okay, what we need is a consistent Schrödinger equation. That's because there are actually a couple. There's a couple different iterations you can put on it, so... We need something consistent, something we can always look back on that won't change textbook to textbook. And so, as such, we're going to pick... Oh, I'm glad I explained this notation before this video. That's good. We need something because they make it looking through the second least consistent field in theoretical physics. Was it the first? Was the most inconsistent? You got me curious. Yeah, I suppose this one could be good. For Schrödinger's equation, is a statement of standard Poisson special equation for a single non-relativistic particle in one dimension. I think that's perfectly reasonable, if I'm to be completely honest. Timon.
Yeah.
Italian Mappa is asking if you've been manually breathing.
There's your answer.
Hey, I'm just a messenger. Make it make sense. I agree, Italian Mappa. I agree. Hi again. What are you all doing? Oh, you know, the usual quantum mechanics, coding cosines in assembly using the Taylor expansions. Basics. The black hole is really necessary for the explanation of memory. I do want to keep just adding black holes to more and more. That would be such a funny recurring bit where I just add black holes into random videos with no connection to the topic of the video. In the quantum mechanics video, I'm going to add a black hole for no reason. The least consistent field is string theory, by the way. But do you really want to call string theory a field? It's purely theoretical. I wouldn't call quantum mechanics theoretical. That's a wavered statement. Quantum mechanics is the applied theory we use. Square-cool black hole. Okay. So we have the equation, then imaginary numbers.
Oh, this is so long.
Did you just sneeze?
Yes.
Bless you. The Discord
Thank
cut it
you.
out, so I want to make sure. Did I mention I sleep with my 3D printers, so if they go wrong, I am there to give their emotional support. Relatable. I mean, in general, not to me, obviously. Why would I sleep with a 3D printer? That's an odd thing to do.
You would never.
I would never. We need more black holes in your videos. Also add about time dilation energy not being conserved when adding it. Energy not being conserved. Are you certain? Are you certain that when you add the time dilation, energy is not being conserved? Because I thought that was the whole point of relativity. To conserving everything, despite everything being relative. I thought that was the whole genius of it. Oh, maybe I'm wrong. I don't know. I haven't actually. I don't know much about relativity. I do mention it a lot because I know the surface level that's like required to work with quantum mechanics, but not much. Call me Heisenberg the way I'm uncertain on principle. Energy's not conserved. Is that what really?
There was a Veritasium video about it a few days ago.
About energy not being conserved? Really? What?
Yeah.
Like,
Never heard of it before Veritasiums, and so I'm a bit skeptic about how strongly I should understand it because the past video, the
I am
vortex or that was what.
with you on that because in the title it says energy is not conserved, but I am skeptical. Can we?
Yeah, lately I've been skeptical with Veritasium videos in general. Like,
With the symmetry, Einstein, covariance, principle of least action, new equation, escape from Germany. Energy is not conserved if you do not count the deformation of space and time field. Why would you not count it? No, I think Veritasium is right, but at the same time, I think Veritasium is extremely clickbaity. So if Veritasium says something in the thumbnail of the video, I don't think it should be taken with a grain of salt. I think it just shouldn't be taken at all. The thing is, when they say, you know, don't judge a book by its cover, in this case, the video is completely disconnected from the cover 90% of the time. I'm not saying the videos are bad, because they have pretty high production quality, there's clearly a lot of care there, but the thumbnails and titles are just... The reason why I haven't seen any of these videos is because of thumbnails and titles. I just cannot even... I can't even click on them. My body refuses. So wait, are you all certain that energy is not conserved? Because I find that highly questionable. That's like one of the cornerstones of physics. The energy is conserved. The thing is, listen, we disagree with Timon a lot, alright, about things that we both consider obvious. If both of us say that energy has to be conserved, that's a pretty solid point. Hold on, conservation of energy. Let me see if maybe there is like some kind of exemption to it.
I'm not saying that that oh my god, this has to be. All I'm saying is that Veritasium isn't a valid source. Like, if someone's gonna change my mind about energy being conserved, it is not gonna be Veritasium.
Oh no, then I disagree. I think Veritasium is a valid source, but I just think energy is conserved. A common feature for me, nothing because of no theorem. Special relativity. Energy momentum 4 vector, yeah, we've got components. What cause conservation of energy over time? As long as reference is unchanged, yes. Disagree as to the energy value, not obviously. Also conserved and environmental observers is the invariant mass. Veritasium is a valid source, but no means a good one. I think with videos, if you understand them precisely, then fine, but don't judge a book by its cover.
Like, it's not like.
An example he
Veritasium
gives is
videos.
the lost energy from the redshift. Lost? I find calling redshift as losing energy questionable. Because it's not really losing energy. I may be completely wrong enough in this case. As I mentioned, my relativity knowledge isn't all that vast. Isn't redshift a matter of observation of the observer? So depending on how you observe light, it can be redshifted. Because that's the only way that like energy could be in quotes lost in that case. But that's not really lost. Tends to oversimplify and omit important points without disclosing it. You see, the reason why I don't want you all to be too hard on Veritasium is because I also do that. Well, I do disclose it. I do mention a lot in my videos how things are oversimplified, but I still omit important points, so you know. I want the benefit of the doubt.
I just genuinely don't like. It's not against Veritasium. Veritasium makes amazing videos. It's that YouTubers, like edutainment YouTubers who make videos for the entertainment of the people, are not a valid source of information.
I agree with that.
Like,
don't use my videos as a source either. That's why I link my sources.
yeah, like that's why if as I said, if someone's gonna change my mind on conservation of energy, it's not gonna be Veritasium. It's gonna be a physics professor.
Immoral, it's not that I don't trust you, I just don't believe you. I don't. Is there a single, because general relativity, new phenomena, for the redshift, spontaneous intention, vacuum energy of the universe appears to be spontaneously increase as the volume of space inverses. Energy is no longer meaningful conserved in any identical form. Okay, that may be it. That maybe that's the claim. Some scholars claim that energy is no longer meaningfully conserved in any identifiable form. Visual momentum is not well defined except in certain special cases. Energy momentum is typically expressed out of the aid of stress energy momentum pseudotensor. However, since pseudotensors are not tensors, tensor, by the way, we all know that tensors are the objects that operate as tensors. That's the definition. They do not transform cleanly between reference frames. The metric under consideration is static. Doesn't change the time. Most people have that. Conservation holds without major pitfalls. Practice some metrics, notably this one appear to go in the universe, do not satisfy these constraints, and energy conservation is not well defined. Besides being dependent on the coordinate system, so tensor energy is dependent on terms of tensor energy, for example.
That sounds an awful lot like the thing you said about redshift. Like that just sounds like the.
Yeah, but in this case, it's saying that basically energy is not defined well enough in relativity in order for it to be conserved. So when you ask, hold on, Specific global energy, potential energy cancels out the mass energy changes triggered by space-time contraction. This global energy has no well-defined density and cannot be technically applied to natural units. However, for practice purposes, it can be witnessed when accounting gravitational potential energy. The net energy of the universe is zero. This sounds more like just not having a good definition of energy general relativity. Well, good definition for the purposes of conservation, of course. Energy because not well defined, yes. Yeah, it's too difficult for me. I don't feel comfortable judging. I don't feel comfortable ruling a judgment on this. Don't make any claims this controversial based on a YouTube video. Immoral. Don't. Just future reference, just don't. You can, I think it's fine to just learn things from YouTube videos when they're specific, but when it comes to things this controversial in this extreme of takes, I wouldn't recommend. Because this is pretty advanced science, and when I say pretty advanced, I mean pretty advanced. You know it's advanced when it gets to tensors. That's a giveaway. In this video, we'll have to get a fair bit more into waves, mostly due to the eye. This side tangent is far too long. I know. ADHD. Not my fault. Okay, so basically, VXT is comically simple because I mean this is potential energy, which just basically stands for we have no idea. Negative h bar divided by 2m partial in relation to x. That's also simple. Well, ish. That's where we get to the ish. Because explaining this as velocity squared, obviously, explaining this as 1/2 mass, that's the tricky bit. Because if I'm not mistaken, we need the de Broglie, right? We need the de Broglie. Yeah, if there is an h bar which relates to mass, that means the de Broglie is hiding in there somewhere. There's an m as well. The wave function is a complex number to each point x at time t. The parameter m is the mass of a particle. Oh, that's a bold assumption. The potential that represents the environment in which a particle exists. Yes, the constant I is the imaginary unit, h is a reduced Planck something which has units of action. Telling me broccoli. Well, it's the broccoli relation. The broccoli relation. We all know the broccoli relation. This, right. Okay, so energy is equal to, this is just basic, like following up on equations. There's basically classical mechanics in a free classical mechanics in a lab coat, then to the quantum realm, notice that we get this, which we get as h bar omega, which is then this. Now h bar omega is equal to this. That's because why? Okay. That's because okay, this makes sense because basically what we're doing here is we're like moving it, we're like rotating it on a complex plane. The basic idea. The only question is why? And what gives rise to that equation? We can guess away from, yeah, but that's not what we're looking. H bar I partial to T. That wouldn't be momentum, would it? Might be. I mean, in a way, it would make sense for momentum. Wait, so omega is I. Because h bar stays, that's just omega. However, omega is one of the 70 trillion variables that we use to describe waves. Okay, there we go. It's a wave number for time. That's a time wave number. And then we just define that time. So the time wave number is just the I times derivative of time. Is it now? Is it? Or to be more precise, time wave number multiplied by the wave function is equal to the derivative of the wave function times I. Yes, simple stuff, obviously. I was about to say it myself. How do you pronounce the broccoli? Well, I pronounce him correctly, the broccoli. That's the correct pronunciation of that name. Okay, we need a second textbook, because if I keep staring at that one, I'll get nowhere. We need a second opinion. Which will be wave-particle duality, I imagine. And now what we need to find is we need to find the relation we're looking for, which is not this. Okay. Okay, I said okay as if I was about to find something, but I have no idea. So what we need to find is the reason why the time wave number. I feel like if we just did a bit of mathematics, we could just figure it out. However, I'm lazy, so we're not gonna do that. That's the double slit. It's not what we're looking for. What we are looking for. Jackpots for particle waves. Yield the following dispersion relation. Kind of a jackpot, but k squared divided by 2m. That would be divided by k squared divided by 2m. That seems awfully similar to this. If k equals -1, sorry, if k equals I. If k equals I, then this is in fact equal to this, which is suspiciously similar. No, the reason why we get -1 is because the y is right here, okay? We're dividing by an I. Which is not quite okay. This feels like a bit of a hit, but I'm just gonna keep going. Wave packets, alright. Wave packets is gonna be combining the waves, isn't it? Yeah, none of this is gonna give us the answer we're looking for. Wait a second. Am I an idiot? Wouldn't that just be the partial just because? Wouldn't that just be the definition of it? Timon, why didn't you tell me?
What? You didn't ask?
Well then, actually, you're lucky that you didn't tell me, because if you told me, that would be pretty bad, because the I is still there. Yeah, because obviously if we have a cosine, if the t is multiplied by something, derivative... No, wait, is that true? Let me... we can just double check this. It's not difficult mathematics exactly. Desmos.com. Which means that if we have a cosine... Let's do the typical, right? Not cosine 90, cosine of xf plus minus to. There we go. Then, wait, no, we want xf. Yes, actually minus xf. And then the derivative of it, df dx. No, wait. No, wait. No, wait. Wait. What we need is how do I do partial derivatives in Desmos? Should be simple. Because what we need is we need to check the in relation to time, in relation to x. That's true, but derivative. This is how the entire function is changing in relation to x, which is still there. Shucks. Gosh dang it. Hmm. This and this and this. Sweet, okay. The derivative of... Because here's the problem, here's the big one. If we just had negative xf, alright? If we take the derivative dx like this, then that would be equal to f. Like, this fits. This fits perfectly. If our wave function was just nothing, if our wave function would just be the variable inside the wave function, we're golden. However, it's not. And it is instead, in fact, an exponent to I. Oh, wait a minute. E to the negative xf. But then I. And if you wouldn't mind complex, where's complex mode? There it is. Non absolute value convert complex numbers to real. We're getting the complex value of this, but then we multiply it by I. Ha 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 ha. He ha. Derivative of e to the I. We need the derivative. We need to figure out the derivative of e to the ix. The derivative. What time was the derivative of e to the x? I don't remember. What was it?
E to the x.
I know. I was joshing with you. My goodness, you could have. The bit. You could have gone with it. Unbelievable. Kids these days. Trying to get back into programming, but I'm so used to multiplying numbers by booleans that I'm strongly typed languages keep breaking. Use C. C lets you multiply a pointer with a number if you ask it nicely. I do have to say though, we need to find a way. Wait, so question. F e to the xf. Found it. Found the answer. Now we would, in a complex way, we would multiply it by I. Here we multiply it by negative. It is equal. Of course it is, because we just take it out. And as such, in here, we have the e to the, mess. And when we multiply it by the temporal wave number, whatever you want to call it, I have no idea what its name is. It's omega, funky W, and mustache, whatever you want to call it. Then this is equivalent, or equal even, to the derivative, partial derivative on t, also multiplied by I. Now, why is it multiplied by I? Because it's all brought up to the i's power. Damn, that's dumb. That is actually dumb. But I mean, I think it works. Oh, I'm exhausted. I am spent. We did a fair bit lot on today's stream. It's hard to pinpoint exactly why we did a lot, because I mean the things that we did today were, well, we did a gear which fits. We did 3 programs. These are 3. We just need to link them. Which fit, and we did a little bit of research into Schrodinger's, which fits. So it might not seem like we did a lot, but that's only because we did the researching jobs today. Okay, so I think I'm gonna go get some food in me, because I'm hungry, really hungry. Then I'll come back, I'll work on some more videos, and maybe I'll into a second stream. Or maybe I won't. I don't know, we'll see how I feel. And for now, I suppose that'll be it. Thank you everyone so much for watching, and have a great day.